what you see on the screen is a point moving around a circle, a line moving with the x-coordinate of a point on the circle. We assume that the origin of a coordinate system is at the center of the circle, and another line moving along with the y-coordinate of the point. The point, if you watch it, is moving around the circle at a constant velocity. In fact, at a constant angular velocity, if you can read it, of 2.000 radians per second. Now what we're going to try to do is we're going to try to match the motion of this washer with the motion of this vertical line going back and forth. And the first thing that we see is that the washer is moving too fast. Well, the washer is hanging from a fixed point, and we can't do much about how fast it goes back and forth, but we can speed up the circle. Okay, so let's see how we're doing now. If we release this thing, the circle's still too slow. So we're going to speed up the circle another unit. Now the point is moving around the circle at 4 radians per second, and we see that the circle's actually getting a little bit ahead of the washer. Let's watch that again. Release the washer, and it gets behind. So we're going to have to slow down the point on the circle a little bit. Now we're going to slow down from 4 to 3.5 radians per second. We tried 3, it was too slow. 4 was too fast. Let's try 3.5 and let's see what happens. Well, they're staying pretty well together now. That's pretty good. Now one of them's getting a little bit ahead. Which is it? Looks like the washer is getting back here a little bit before the line on the screen. So we're going to speed up the line on the screen. It's at 3.5, it was at 4. We're going to go up to 3.7. And let's see how that works. Now we see that it looks like the point is out ahead of the washer now. So maybe we better slow it down to 3.6. Okay, 3.6, I didn't start that point right. 3.6 radians per second, and they're getting pretty close. Now eventually we'll be able to see which one gets there first. But it might take a while because so far they seem to be staying right together. Now we're not going to refine this, but we've got it down to 3.6. We've got it to the nearest tenth of a radian per second, and that really seems pretty close. We could get it down to the nearest hundredth of or thousandth of a radian per second. We've got 2 more levels of adjustment, and if we let this go long enough, we'll see which way we need to adjust it, and we might be able to determine how much. But right now, it looks like this is pretty close to 3.6 radians per second. 3.60 radians per second. Another thing we can do is we notice that the washer isn't swinging as far. Well, we can make the circle smaller. And now the washer swings about the right distance and pretty much stays with the point. Okay, so we see that this motion of the washer on the pendulum is well modeled by the circle on the screen.